Okay. Okay. So this is assignment 2. So replace your progress test. Huh? Okay. So the induction motor has become the main actuator in automation to get things moving. Okay. Describe exactly how induction motor works and why engineers in industry. Why has engineers in industry chosen this motor compared to stepper motor? Okay, DC motor and synchronous motor. Okay, so that's the first part. The second part basically is about induction motor. So second part is about synchronous motor. Has started coming back in the major field of automation. Apprise why this has happened. Okay, so that field of automation is basically robotics. Okay. So in robotics, they started using synchronous motor. I told you last few weeks is because they're able to control the RMF around the synchronous motor in the signal of synchronous motor. Okay. And then the last part is wait. Okay, so this is the first part. So first part is like this. So this is the first part, only about induction motor. And the second part is synchronous motor. So why has this? Why this has happened? Okay. So synchronous motor is basically come back in a major field, which is basically robotics. Okay. And why this happened? Because previously all robots were made with stepper motors. Okay. So synchronous motor is a much improved method because it can control. Is basically stepper motor can do a very good job. Okay, I showed you the movie of stepper motor in the chip industry, right? Super fast and perfectly accurate. Okay, but the problem with stepper motor in industry is weak. So I was working with Western Data. I told you, I was stronger than all the robots. The robot arm and my arm is much stronger. Okay, the motors for stepper motor are not strong at all. In fact, only one time I got a near crush of my hand, and that's not because of motor, that's because of the pneumatic system. Okay, I told you pneumatic will come on your exam also, right? I showed you already about pneumatic system a little bit. So that is quite strong. Yeah, pneumatic is quite strong. Okay, quite powerful. But motors, not at all powerful. So that's why I keep telling you, sorry, when I was young, I used to bring my children to watch the Transformer movie. So powerful, they can fight each other. I said, impossible, a robot cannot be so strong because motors are not so strong. Stepper motors and robots can never be that strong. But now can, because they're using synchronous motors. Starting 2015, remember that day. Only 2015. Like that. So, including your assignment. Okay, only in 2015, the synchronous motor have replaced stepper motor, okay, in the robot arms. Okay, the reason is because the synchronous motors only in 2015 they managed to use the DSP software. Okay. So they managed to use the DSP software. So DSP software, digital signal processing, which is basically to convert analog signals into digital, okay, which enable the handphone industry to come up very fast. So in the old days, telecommunication was very slow because they actually used complicated calculations to recreate the waves, okay. But now they digitize it. There's big expansion in telecommunications. Yeah, even very poor people all over the world have handphone nowadays. Okay, so only in 2015 they used the handphone software for motors, especially of the current going in the stator of the synchronous motor. So the rotor will follow exactly because the rotor is basically a magnet, electromagnet. When the DSP software make it go out now, the rotor goes, it follows. Okay, it follows exactly. So that's why now the robot arms, okay, the robot arms of motors, they are putting synchronous motors. Okay, it was always stepper motor before because stepper motor was very easy for programming. Because it goes step by step, just like your computer also goes 1, 0 step by step. Okay, so it was easy to do programming with a stepper motor. Only 2015 they managed to use DSP software to control the stator currents in synchronous motor. So they start using synchronous motor. And synchronous motor, there's no limit. There's no limit how big you are. Okay, so I show you one of the synchronous motors. I think I did show you one, but now it's an assignment. Okay. So this is I think I showed you this before, but you see this is 135,000 horsepower from Seaport down to UCTS. I think you must be able to give any horses. Okay, 135,000 horses. Okay, so this is a huge motor, but it's not the largest. I just came across this one in India, 186,000. This 135,000. This 186,000. So this is an Indian company. I think they're using it for pump. Yeah, it's a pump. Okay, so basically the pump has a gigantic 139 megawatt horsepower. Megawatt. Okay, megawatt. Sorry. You know the convert, horsepower to megawatt. You must know. 1 horsepower equal to 746 watt. Okay, you must remember this number. Okay. You must remember this, whether you are electrical, civil, mechanical. Every technical person must know this number. Okay, 746. Okay, so but industry normally they take it 1 to 1, when you on the site, How many megawatt? 40. 40 horsepower. You know, with horse, they can imagine the horses. Eh? You tell them 40 megawatt, they don't know what is it. But with 40 horse, wow. Kuda. Oh, okay, that is a big power. Okay, imagine 40 horses. That's why I like this. This I told you, I think last week. Sometimes the old system is better. The US is still using the old system. You know, the kaki, the feet. Feet is 1 feet lah. Your feet. Okay, 1 yard is 1 step. I mean, we got meters is about 1 step or so lah. Okay, but meters is a big stretch out step. I tried already. I measured it. You must really stretch your leg. For me, I'm quite tall. I really must stretch my leg to get 1 meter. But yard is a bit shorter, I think. So it's really 1 step for a human being. It's about 1 yard. So feet is your feet, and then 1 inch is like that lah, from between here and the first marking here is about 1 inch. So that's why the old system was based on your human body parts and horses. You know, 1 horse. It's a 40 horse. Wow, 1 horse I can imagine. So 40 horse was the power of it. You know, you can imagine. That's you can easily estimate lah. In America, there's 1 more unit they use: football field. That's about 3 football fields. You know, because everyone watch football, and they don't play our football. They play the American football, which is actually our rugby. Okay, so these are important things like, because you watch TV all the time, the football, the American football. So you can roughly know, and then sometimes you go and watch in real life also. You roughly tell how long that is. That house is about 3 football fields away. You know, these are important things like. And then in my factory, it's very easy. You know, we don't need measuring tape at all. The ceiling, we count the ceiling. The ceiling is 4 feet, 4 feet by 2 feet. So we want to put machine that side there, beyond that person there. Okay, let's count the ceiling. Okay, that's about 16 ceilings. 16 times 4. Yeah, 16 and 4 is the distance. How many feet away it is lah. Okay, so that's why in industry, I mean in construction industry, people still prefer, even now in Malaysia, people still prefer the feet. Okay, and I think the specs like electrical specs. You must put the earth, you know, earth rod. Earth rod you sink into the ground, but you join it. You must join them, right? If you put 1, you get that much resistance. You put 2, lower the better lah, right? But you don't join it on the top, on the surface. You know, people steal. And also, they want it at the bottom. They want it 1 feet below ground. Okay, so it's 1 feet below ground. They join it. Why? Because it's bare wire, bare copper wire. So that one being underground also helps in your lowering your resistance. Okay. Okay. So if you say it's 1 feet below ground, people can easily estimate lah, like 1 of my feet. You know, people digging the ground using a hole, a charcoal, they can easily estimate lah 1 feet. But you tell them 300 mm, okay, get me measuring tape. Okay. So it's difficult lah. Sometimes you don't have access to measuring tape and all that. So recently I bought a new measuring tape. I'll show you tomorrow, but okay. Here's my measuring tape box. This is my measuring tape. Okay. You just press, it will tell you what distance. Here's an LED basically. So you press between here and here. It tell you how many mm it is. What's this going on here? Oh my the figure doesn't do very well. The wall is okay. The wall to me is about 0.7 meters. But this one, the figure, try this one. Okay, this is 0.16 meter. Okay. I guess it doesn't do well with black. Yeah, it's 0.16. This one. Anyway, and because I keep wearing, so the result is not accurate. This one will be more accurate. Wow. But when I shine the wall, no problem. Straight away give me an answer. Okay, that's 0.2 meters in here and here. Okay. Try to bring it to class tomorrow. Okay, tomorrow. Do you know if tomorrow is still shut down? Never mind, we just go to class tomorrow. I think it's okay. Let me check. Wow. 10 May. Announced that Sahara disaster has extended. Let me show you this one. No, where is this? Okay, here. Okay, this is today. We'd like to inform you that Cebu Division Disaster Management Control, announced by Sarawak Disaster Committee, has extended the enhanced standard operating procedure under the outgoing conditional movement control order in Cebu, in fact from 27 April until 10 May. Under the enhanced SOP, one of procedure is that only essential services are allowed to operate. After consulting and approval from the top management, HCT would like to inform all staff to adhere to the direct. We'll stop all physical classes, lab, studio work. Okay. So tomorrow we'll continue online. Okay. We'll do the software online. Staff are restricted to travel. Wow. Okay, staff are advised to restrict your movement at home. Okay, staff who are with the university and other staff mentioned above who need to come to the university first must follow the SOP. Must ensure maintain a high standard of hygiene. Staff will need to clock in. Face mask, also not together in a pantry, whatever. Okay. 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 So we're gonna have class tomorrow. So it's good for you. Okay, Cheng Hong especially. Cheng Hong from Serike. Now to come to Cebu. Okay. 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 So I don't know. I need to. Yeah, I need to get special permission to go to Kuching because I project Kuching. I got this project Kuching because I go every weekend to Kuching. Anyway. Okay. Okay, Sheng Hong, you are a bit lucky. You need to drive 1.5 hours, 3 hours to get to class. Okay, so that's your first part is about induction motors, and that movie is quite important. You know, I showed you the movie about induction motor. All of that you can put in. Okay. So the first part is about induction motor. So maybe I will send you the link to the movie. You can find it. Let me show you this one. See, it's now 90% of industrial shapes industrial motor. It's 90% of industrial movements are done with industrial motor. Okay. Is this the one? Let me see. send you this one. See, this is not the one I last time showed you, but oh. Let's see. Yeah, this one. Okay, so I just sent you the two videos. Okay. The first one is what I always refer to. It's more detailed. Okay. The second one is what you just saw. I mean, just now was the first one. Just before that, so the new one. Okay. It says that 90% of all industrial motors are induction motors. Okay. So not all home motors are induction. Like this fan here is an induction motor. It's a single-phase induction motor. Okay. You must remember that a three-phase induction motor is more perfect because you see, as Bakun rotor turns, a Cebu three-phase induction motor will turn exactly the same. Okay, so it will turn exactly the same. So it is actually the three-phase induction motor was the original creation of Tesla. Okay, the single-phase one is a modification. I think I showed you, you refer to your former notes, how they modified it. How they modified the single-phase motor to be able to run. Okay, they need to put a capacitor inside. All single-phase induction motor, like this fan here, has a capacitor inside to enable it to run, to basically power the starting coil. You see, you got two coils like this. It's only single-phase, not like in the Bakun, you got red, and then you got yellow and blue, right? But in the single-phase, it's just one, red. So they got to put another two coils here, basically one coil, one wire, making two coils. But this one goes directly to red wire, okay, red phase wire. But this one, the red phase wire had to go through capacitor before it goes to this one, okay. So this is called a starting coil, and then they put a centrifugal switch there, centrifugal switch, okay. After it's already turning, the switch will open due to centrifugal force. So this starting coil will disconnect once it started turning. So remaining only this one. So why? Because this one is already, you see, buckle is already turning, so you can follow, right? But between here and here is too far. So they need to put a starting coil here to get it to start. In the old days, how they do it, they use manual. You know, like old days, I don't know if you've seen very old movies. To start a car, they got to turn. Okay. Okay, similar to our generator here that we just got it to power last Thursday. I show you. This is how it worked last week. We got our micro hydro to work. I mean, the small version of it. Later, we're going to expand it. This is a generator. So the Archimedes screw turbine is turning the generator. So the bulb is working, not so perfect, but we will stabilize it later. About 8 volts. So we use a pump initially. Later we replace the pump with the river water. Okay. Okay. So for the first part, assignment, you have to watch the 2 videos I just sent you. Okay. the main actuator in automation, just now that video, second video says 90% of industrial movement is using induction motor. Okay, worldwide. Okay, so exactly how it works and why is engineers in industry chosen this motor compared to stepper motors? Okay, I mean, there are basically three motor stepper motors. I mean, there were a lot of motors before, but now it's just basically induction motor, Tesla's motor, basically. Stepper motor used mostly for the robots, but they're gradually being phased out as synchronous motors are coming in. Let me send you this again, because there's now some wording changes. I'll send you the assignment again. Okay. Okay, so go through again. Okay, so you have to watch the two videos to answer this first question, the induction motor. And then the stepper motor, DC motor, synchronous motor. Okay, why induction motor is replacing? Okay, the second question is synchronous motor has start coming back in a major field, which is basically robot arms. Okay, why? Because it's so powerful. Okay, just now I showed you 135,000 horsepower. Okay, whereas stepper motors, at least in Western Digital Kuching, my hand is stronger than all the stepper motors. I mean the robot arms, basically. My hand is stronger than all the robot arms. Okay, so synchronous motor, 135,000 horsepower, that is a transformer movie robot already, or stronger than that. Okay, and then the third part, and you must describe synchronous motor. Huh? Oh yeah, you need a movie with synchronous motor. Let me show you. What's the link for that movie? This one. Just say. Okay. Okay, so for the show you assignment again. For synchronous motor, I just send you the link. Okay. And the reason why it happened is basically what I told you, 2015. They started using DSP. Okay. So basically, starting 2015, they started using DSP for to run synchronous motor. So that's why it can be very accurately controlled. So they can use it for robots. Okay. Okay. So that's the reason. That's the answer for that question. Okay. So the next question is why a motor starter is needed. Okay. So this one I think we need to take some print screen from my slides and show you. Right. Where's my okay. Okay, so the question is about Autotran. So you need to take print screen of this slide. Okay, take print screen of this slide. Okay. This is Autotran circuit. This is a power circuit. Okay. Then you have the control circuit later. Okay, so this is the power circuit. The control circuit, you have to take another print screen here. This one.
So do you show anything?
Nothing?
My screen is show the assignment.
Oh, sorry. Let me do it again. Okay, wait. Now you see it, right?
Yes.
Okay, wait. First circuit is this one. You take print screen of this one. This is a power circuit. That means the big wires. How big the wires? According to motor size. You got small motor, 5 horsepower, the wires are smaller. But if you got a motor that's 40 horsepower, 40,000 horsepower, 40 kilowatt. Okay, so I said 40 kilowatt, then of course the wires are very big. Okay. And you got like just now 135,000 horsepower. Okay. Then you have super huge wires. Okay. So the wire size depends on power. Actually, the wire size depends on current, not on power. Just remember, wire is always depend on the current. In electrical, you got 4 things. 4. PVIR. Okay. In electrical, you got PVIR. But the wire size the wire size only depends on the eye. Out of 4 things, only the eye will determine the wire size. Okay, it's not a power, it's actually the eye. Because power you can change V and I. Okay, with one power you put different V and I, you can vary the wire size. Yeah. Okay, so okay, just now let me show you the power circuit again. So you take print screen of this. Remember, this is useful even for your judgment later, because this one currently come out in your judgment exam. Okay, and this is your control circuit. Okay, take print screen of this. Yeah. You see, sometimes I put like L2, L3. They're just name. You can give any name you want. Okay. It is important in circuit that you put a name so you know where you are. Oh, L2 already do, now I'll do L3. Okay. If they all look the same, you get confused a bit. Just like last time I was doing a bit of wiring. Okay, I'll show you the wiring I was doing. You already take print screen, huh? This one you need it for your assignment. And your exam, huh? Final exam. Final exam, I wouldn't ask you to control circuit. Where this power circuit, you must give it back. Okay. Let me see, where was it? What's up? Wow, so slow. Okay. Let me show you. Okay, this is something running last night. Initially, I did without numbering. Okay, I think it's somewhere else. Okay, I was doing this wiring last night for Reno. And then initially, okay, it's simple. Just trying to do this again. That's about it now. And it also be confusing because they're all the same thing, and I get confused which is which. Then I start putting number on it. I put number. Then I know, okay, that's the first wire. Number 1 means first wire. Number 2 means second wire. Then I can do it properly. See? So that's why it's important that you give a name to it, because they're all the same thing. See, all these are all contactors. These are all contactors, and these are 3 solar panels. So if you don't give a number, your mind don't know what is it, where are you? See? So that's why you give numbers and names to things. Okay. So that's exactly the same reason. That's exactly the same reason why you give name on this one. See? They are the same thing. Okay, this and this are exactly the same thing. They are the same contactor. but different holes. But if you don't give a name, you don't know which you have done, which you have not done. See? So all these are contactors, say like S1T, no, not T, yeah, T. S1, T1, and L1, they are all contactor, different contactors, but they are, they are same contactor doing different function. Okay. Okay, how it works, let me show you. So this is the circuit. Maybe you take a picture of circuit also, the physical circuit. Okay, you print screen this one. This is the self-metal circuit. Okay. So basically how it works is this is Autotran. This is red, yellow, blue. Okay. There are three different coils in the same housing. There's no connection between this coil and this coil and this coil, okay? They just use the same housing. The housing is called a core, the iron core. It's using the same iron core, okay? So what it does is, you see, there are three wires here. Two of them are the end of the coil, the beginning of the coil, end of the coil. The middle one is somewhere around 70% of the coil. If the coil has 1,000 turn, around 700 turn, they use a pen knife to scrape out the 1 inch and solder a joint to that point. There were 1,000 coils, 700 turns, 100 turn, right? Sorry, 1,000 turns. At 700 turn point, you just strip off the 1 inch, the 1 inch from the wire, because the wire is covered with 1 inch, right? You scrape it off and then solder a joint out. And that is a third wire, the middle wire. The middle wire is 70% wire. So what this function of this Autotran is to split the voltage, just like resistor. You know, you put two resistors, you take halfway between two resistors, it gives you half the voltage. Exactly the same thing. In big power system, they tend to use this one instead of resistor, because resistor use power. Okay, to send current to a resistor, energy is wasted to heat, right? This one, there's very minimum of heat. Yeah. So in big power industries, not much in Malaysia, but in Western countries, I see a lot of big power modifications that they do, especially to get DC power and stuff like that. Okay, to get DC power and stuff like that, they do a lot of stepping down the voltage, and they step down using this method. Okay, instead of resistor, they just use these coils to step down the voltage. Okay, so basically how it works is like this. So, okay, the red, I just draw one face here, that means the red. The red will go here after the contactor. You go to the top of the coil. Oh, that's the. Okay. So this is the top of the coil. The 1.5 is top of the coil. So the red will go here, and no, the red will go here. Go through this contactor and go to the top of the coil. Okay, and then the other side of the coil, the bottom of the coil, is this one. Okay, so when you see the star, that's actually the bottom of the coil. How to get the bottom? They use looping of red, yellow, blue. Why is that possible? How can you loop red, yellow, blue and get 0 volts? You see, to get 0 volts, there are three methods. Okay, to get 0 volts, you use 2 methods. Okay, so you can either use neutral, which is most of the world is using neutral. Okay, or you can use earth, which is used in some places. The earth rod is the other side of the equipment. That means the wire come to your house from the Cisco wire, it goes to your TV. Other side of the TV is your earth rod, your house earth rod. There are some places doing that in Australia, for example, the farms, they do that. But it's actually not allowed in Malaysia to do that method. Okay? Okay? The law, our electric laws, they cannot. Okay? Because that enables people to steal electricity. So that's why they say by law cannot. Okay, and the third method is star point. What do you mean a star point? You just join all 3 wires together. Seems strange, huh? Phase wires you join together. Why is possible? You see, if you join 2 phase wires, red, yellow, like my school, I have a school, so the students are make mistakes. If live to neutral, they short it. It's like, one person standing here, next person standing next to him. The next person standing next to him also don't know he did that. The sound is very, very low. Okay, live neutral short. Okay, but face to face is terrible. The sound. Like my school is about 90 feet by 60 feet. Okay, the whole 90 feet can hear. Even down the steps, because my school is one level up. Even down the steps, I can hear that loud the sound. So it looks, the numbers don't look different. Okay, if live to neutral is 240 0, the numbers just 240 0 on it. But face to face is 415 to 0. Yeah, basically it's 415 across this. Okay, here is 240 across these 2 wires. Here is 415 across these 2 wires. Okay, so you see, I don't think a human can survive the 415 shock. If you touch 415 volts, I don't think a human can survive it. 240, I myself have touched probably 300 times because I'm doing electrical work since since I was very young. Because my father was an electrical technician. All my brothers are electrical engineers. Before we were electrical engineers, we were at a repair house, one of the repair houses of Kuching right now. People send all the electronic equipment to our house. We had a repair house. Okay, so I got shocked a lot. Okay, so about 300 times I touched. So 240 volts I've touched. I've never touched 415. And from the sound difference, from my own experience in my sound difference, I don't think a human can survive 415. There's one historical case of someone who survived a shock of some kV, some 22 kV or something like that. Okay, so this was a Cisco guy. The technician told me. So his boss name is Selamat Wong. He's an engineer in Cisco. His name is actually Selamat Wong. He's a Chinese guy from, I don't know exactly where, but somewhere, Serike maybe? Somewhere there, Serike, Bintang, somewhere like that. Okay? So what happened to him is when he was a baby, he just born. He got sick, really sick. So the father expected him to die. Not survive, okay, as a baby. So the father, no choice, brought him to a Bomo, okay, and the Bomo saved him, okay. So the father named him Selamat Wong, okay. So that's how he got the name Selamat Wong. So he became an engineer, and actually at that time he was just a manager. Now he's a very big boss in Cisco. He's quite a big boss. I don't know what position, but somewhere near Vice President, that kind of post. Okay. So he was just I think that time he was just an engineer maybe at the time. So his technician told me a story, his direct technician. So he asked the technician, can you go up the pole and do the testing, the injection of voltage to the lines. They call it high pot. High pot, that means you inject very high voltage to the line to see if the line can handle it or not. Okay. So he asked the technician to go up, but oh no, don't dare. Why I want to go up the line? So he went up the line himself. He got shocked. And it's just his safety belt saved his life. He was already hanging from the pole. Everyone thought he was dead. The safety belt saved him. So 2 times he was saved. From baby, he was saved, and on electric pole saved. I think he got a big function in this world. It's my theory. God wanted him to be alive. Okay, he has a big function in this world. That's my theory. If you have near miss death 2 times, God really wants you here. Okay. Okay. So anyway, 415, I don't think a human can survive like you touch it for a long period. For Selamat Wong case up the line, it's possible he didn't even really touch the wire. Because at 22 kV, you go close enough to it is enough. Okay. You don't need to touch. 11 kV also, you must remember, there's a serious accident. People, I know of 2 cases. One is my friend's, my friend owned the scrapyard. And then his man was putting a signboard, they use tin can to make sign on the scrapyard. But there happened to be 11 kV line. You remember 11 kV is bay wire. Only the overhead near your house has insulation. But the 11 kV are normally bay. Very rarely they have plastic covering. The only place that I know that has plastic covering is Semonggok Wildlife, where they raid the orangutans. Okay, so the orangutan tend to go on the live wire and get killed. So they put plastic covering on it. But normally, SESCO prefer never to put any covering on it, because when you put covering on a wire, it's just like you put a jacket, very hot. You put 2 jackets, very, very hot. You put 3 jackets, cannot stand. You're shaking like hell. The shaking electron is the R, the resistance. Okay, so when you transmitting a very big power like 11 kV, 275 kV, those kind of power, is always bay lines. The bay is cool, so you can transmit a lot of power. Okay, you can see this table. This is used by all wiremen and chargemen. Let me show you this table. See, this is the IE table on how much. You see, these are the size of the wire. Okay, 1. This is 1.0, 1.5, 2.5, 4.0, 6.0. Why put so many zeros? Not nice. Anyway, I try to get rid of the zeros. So it's just 1, 1.5, 2.5 like that. Okay, you look at this. Cross-section area, this is how the wires are named. Okay, 1, 1.5, 2.5 like that. Okay, in the very old days, it's clip direct. That means it's clip direct. That means, like my father's house, 1968. 1968, the wires are clipped direct on the wall. You can see the amps. So if you want to see the amp, you look at this 15.5, okay, and you look at this in conduit on wall, that means the conduit is fastened to the wall. That means the wires are in the conduit fastened to the wall, okay. And this one, in conduit internal insulation, what's the meaning? Let's compare apple to apple. Clip direct 304, in conduit on wall 304, 304. So we look at all the 304. Huh? Clip direct, okay, look at the first wire, 14. In carry 14. In conduit on wall can carry only 12. You see, reduce the amp, right? In conduit internal insulation, which is most of the houses nowadays. You don't see conduit on the wall anymore. It's all inside the wall, right? That means it's internal insulation. Look at it, 10. So that is like almost 4 amps reduction from the clip direct. From here to here, just now it's 14. Clip direct is 14. Now it can only carry 10. What's the meaning of this? The more you cover your wire, the less it can carry. Okay? Your carrying capacity is reduced when you cover your wire more. Okay? So where is the most covered wire you can find? Underground cable. Okay, let me show you underground cable. Okay. Okay. So this is underground cable. So much covering. Very hot. Okay. In fact, this is quite incredible plastic because I have one of my tables in my school in Kuching. Between the conductors, it's just about 2 cm, you know. I told you just now, people got electrocuted in this the scrap yard because he was holding a long metal pole near 11 kV. Near, I'm not touching. It's just near the 11 kV, and he got electrocuted. Okay, this one is just 2 cm. You know. So obviously, underground cables are terribly expensive. From 11 kV, they can fly through air to your pole that a guy is carrying and got electrocuted. This one is just a plastic, which is just 2 cm. And they're talking about 1 to 2 kV, 32 kV. I mean, 11 kV enough, you can fly through air. This one is a thin plastic. So what happens normally in this underground cable, if there's a stone, you know, sometimes they don't install a cable properly underground. So there's a stone below the cable. Eventually the stone will decrease the space between the plastic because it's 2 cm. If a stone is compressing it, it becomes less than 2 cm. Eventually you get a shock. Okay, it would be an explosion. Okay, so that is why underground cable with 2 cm compared to air, you can fly through air maybe 1 or 2 feet. And this one 2 cm, you can imagine how expensive that plastic is. Okay, that's why underground cables. This is the story of underground cable. Let me show you. This one is undersea cable, pretty much the same. But you look at how much plastic is covered with. They have holes here to send water through to cool it down a bit, but it's still terribly expensive. I show you the specs here. Cost 8 times higher than overhead lines. That means 1,000 will get 8,000. 80,000 becomes 800,000. Sorry. 100,000 become 800,000. 1 million become 8 million. 100 million become 800 million. 1 million become 8 billion. I mean, so it is terribly expensive. I heard bigger figures than this. There are people talking about even more than this number. But this one is from an American utility. They give these numbers. I think I wrote, here, Georgia Power Company. Okay. So 8 times more, lifespan only half. You spend so much money to get half the lifespan. It's crazy. Okay, so it's 35 years versus 80 years. Repair time, 1 week. Crazy. Imagine the line, you know the line in front of UCTS, just in front of KLT, that is supplying power to the whole Cebu. That's basically the incoming power for the whole Cebu. Okay, that's 132 kV. Okay, that's coming from Oya Road. Oya Road is the incoming for Cebu. So it's going through that 132 kV and going to Cebu. Okay, imagine that one is underground, and then somewhere near KLT, someone using a tractor dig the ground and cut it. I mean, if people obviously know that they cut it and then they tell Cisco they know what to do, okay. But if someone, I cut it. I think I cut, but I don't tell anybody. I quickly cover the ground and don't tell anybody. Cisco need to troubleshoot. Where's this break? You take 1 week to find the problem. You take 1 week to find where it's cut. Okay, the whole Cebu out for 1 week. Imagine that. The whole city of Cebu, Cebu City, I'm not sure. The whole city of Cebu has no power for 1 whole week. You know how much money Cisco lose because Cebu no power 1 week, and the whole Cebu will be a mess. The traffic jam will be like crazy because no street light working. People cannot cook. The people, I mean, probably even the water supply won't be around because no power, no water supply. Okay, so a lot of issues lah. Okay, maybe water supply got backup generator, I'm not sure, but probably it's difficult for them to sustain it for 1 week. Okay, so 1 week Cisco will lose millions. Okay, I mean, maybe I heard some super rich people in Cebu. I know because Wong Hao Ching, he worked in a restaurant in Cebu. He told me he worked every day, every night. He said that his one table cost 3,000 ringgit. The bill, one night they eat 3,000 ringgit. And then he said he has seen people coming back 3 times a week to spend 3,000 a week. Those kind of people, their house aircon bill maybe 5,000 easily. They're non-stop aircon, 24 hours. Okay, big house. So one house like that. So maybe there are a few hundred of those kind of people in Cebu. Each of them bill like 5,000 to 10,000 a month. All that Cisco cannot get because 1 week. 1 week, no, there's no power. Okay, so if you look at all this, underground cable is terribly not logical at all. I was teaching a class like this. CIGB asked me to teach classes for contractors so they can renew the license. So I'm telling all these problems in the media class. I mean, all the contractors come to my class now. So I told them all these problems, and then one contractor hands up. There's one advantage underground cable. Make me a lot of money. Okay. There's no other advantage. It makes the contractor a lot of money. Okay. 100 million project will become 800 million. Of course, he can make more. He can make much more money. Okay. And then the only advantage is beauty. Can stand typhoon, but it's not a case for us because we don't have typhoon. Okay. So some of you, maybe your FIP now, you make the lines beautiful and make a design to make our headline beautiful, put mirrors on it or something, I don't know. Mirrors might work actually because mirror is silicon dioxide, which is an insulator, so it might actually work out there, but the problem is it fall down and crack on people's car and all that. I don't know. Your FIP maybe can suggest this one, how to beautify, because the only thing about underground cable is beauty. So There's no other advantage or everything disadvantage. So we should actually be using overhead line for everything. In the only people who will like this is the contractors. Contractor means the politicians and everyone in the chain who get money from the projects. So what happened in Thailand, where the king is super rich? I heard he's one of the richest men in the world. How I know is, you see, in India, my father was a World War II soldier, so he fought the Japanese in Burma, and then ended up in Singapore to Cebu. Actually, his first point in Malaysia was Cebu. I was working in the airport, basically our university. That's where I was working in 1958 during British time, So my father's place in India, they had a king, and recently they found in his temple $400 billion of gold, and they haven't opened up all the vaults yet. And the state, my father's state, is not so big; it's smaller than Sarawak. Okay, and they have 400 billion. Imagine what Thailand king has, because Thailand king was a king for much longer time. So the king, Thailand never got conquered like Malaysia. Okay, Thailand was Thailand since the beginning of time. I don't know when was it Thailand, and basically it was never conquered. And for all that time, in old days, king means they have all the property of the country that belong to them. So that's why I heard the Thailand king is one of the richest men in the world. So you know how normal business work. Businessmen go contract, give kantao to a politician, and that's how normal business works, lah. But how you give kantao to the Thailand king who has so much money? Money is nothing for him. Okay, so you can never corrupt the king. So that's why in Thailand, the king said no underground cable. So in Thailand, it looks ugly. All the lines are overhead. Telecom, power, everything overhead. It looks ugly, but I tell you, it never fails. It's so cheap. Okay, like my friend was working for, here to get internet, you got telecom, and then you got Maxis and some others lah. But in KL, there was one other company called Times. So one of my friends from Kuching, he worked for the KL company, Times. And I said, Times will promise you so many, gigabyte and all that. But in the end, they give you very little. Why? They put all their telecom lines underground. In Malaysia, how you put underground, always flooding. So all the switches get flooded with water, they get destroyed. In Thailand, it's all overhead. Lasts forever. Easy to troubleshoot. The power is easy to troubleshoot. The internet easy to troubleshoot. So right now, if you check, Thailand has the cheapest internet in Southeast Asia. Okay, and very high data rates. Okay, so that's why overhead is still the best lah. The only disadvantage is ugly. I can show you some ugliness in Thailand. Okay. Okay, these are some Thailand lines. Look at that. Very ugly, but it works. So you can do FYP, how to make this beautiful. Since only advantage of underground is beauty. Can't someone work on beautifying this thing? Put mirrors on this or something? Maybe not really glass mirrors, maybe the other things can be mirrors. I don't know, maybe some, I don't know. had to think about. I never think of this, but in the back of my mind, I was thinking, why can't someone do this? Make this beautiful. Put mirrors. I don't know. Somehow, I think there's a way to do this. So this is. Okay, look at that. It works. Everything works very well. Maintenance easy, and they have the cheapest rate. Oh yeah, they got some kind of problem with this. Okay, but even then, I can tell you, this is easier to repair than underground cable in Cebu. Because some burn here and there. Okay, they'll come join the wires. They don't even put new wires. They join the wires where it's burning. They join it up, fix it for you. Within probably 1 or 2 days, it's up and running. Okay. Underground, you got to take this whole place, cement it, or road is terribly expensive, you know. To dig a road, it's because roads are. When I first joined CESCO, they told me the figure is 1 million per kilometer. That was what, 27, 28 years ago. Okay. Now, I won't be surprised if 2 or more million. I heard Pen Borneo is 10 million, someone told me. Pen Borneo is 10 million per kilometer. Okay. So to dig a road and then resurface it is terribly expensive. This one just wires. I think nothing. Okay. So there's a big issue. Thailand looks ugly like this, but everything works. Okay. Their system works very well. And people can repair it also easily. See, like this guy here. Okay. So they got one good thing in Thailand now. Okay, everything is overhead, so they get the cheapest electricity. I mean, hard to compare with Sarawak because we got free electricity, right? But anyone like them using diesel, I mean, they're using mostly gas turbines. Even any country using gas turbine, nobody compare with Thailand because they have overhead lines. Okay, most of Western countries are going underground. Japan is fully underground. Korea, Seoul is mostly underground. Okay, but there's huge losses in underground cable now. Okay. So okay, the assignment question, you have to take the give me these two. Okay. Oh, sorry. So you must give me this, and then you must give me this, the control circuit. So the control is basically like a small little computer. Okay. A simple computer to get a system working. Okay, but it's using contactors. So contactors like this. These are the contactors. Contactors. Let me see. This one. These are contactors. This guy, I was teaching this guy in Cebu. He's a Kapit guy, CESCO guy. I was so impressed by his wiring, so neat and tidy, so I took a photo of it. And later I found out he failed. He took time to make it so pretty. Exams only 2 hours. He failed. Okay. The CESCO spec is you don't need to be pretty. You just get the thing working. That's it. You pass. Okay. Because you see, there's one guy doing this in Kuching as a business. Okay, he make things work like that, and he's older than me, and he takes 2 days to do it. Of course, when you do it professionally, he make it very pretty and all that lah. Okay, but when you're a professional who is older than me, all his life in electrical, take 2 days to build it. You don't try to make 2-hour exam pretty. Okay, that's the idea. So in the exam, make it ugly as long as it works. Okay, okay. But the naming is important, like I said just now. That's why we give names like this. Sorry. Say. Okay. Another one. Okay. So remember, principle is one. That's why we give names so we know where we are. Now your mind will be thinking they all look the same. The holes all look the same. Where am I? Oh, this is S. So the contactors also, all three contactors look the same. So your mind will be which is which. If you name it, this is S. I've done S already. Now I'm going to do D. See? If everything the same, you give it name, then you know which is which. Okay. The idea is like house. You want to you're a postman delivering to different houses. You'll be confused. Okay, this row house number 3, this row house number 4. Even that is a name, but without a name, they cannot really deliver to your house. Okay, so that's the whole idea of giving names. Okay, you look at the connectors; they're all the same. Okay, I was doing that last night. And they're all the same. The holes all look the same. The contactors also look the same. You see, this top part is extensible. You can take it out. So you already done one, and then which one I haven't done? Which one I haven't done? By giving name, you can do it properly. Okay. You can. Oh, I've already done number 1. Now I'm doing number 2. I did number 2. Now I'm doing number 3. Okay. So you give names to the holes so you know how to do it. I think people are having big problem with this because I know Dr. Ramli, his FYP was saying, because it's so hard to do this circuit, we have to create some other system. That means other people are finding big problem with doing this wiring. Okay, so he is trying to do some chip method. I mean chips. I think Tri-X or something, to replace the contactors, but it's not really logical because the Tri-X that can handle the big power is terribly expensive, so it's not worth it at all. Okay, because these things are very common worldwide. Okay, and they've been used since much before World War II, and because it's very old, very standard, so the price goes down a lot. Okay, you want to make a Tri-X that can handle this big power. It is not many people building those Tri-X with high power. And you're not talking about small, you're talking about very big power. Like the FIP did control one small bulb. You're talking about this big power controlling big motor. I mean, it's not logical at all. Okay, to use a electronic to replace a contactor. So that's how the world works, Things have all people have been building it all over the world for a long time, 100 years. So the price will go down. It's reliable also. Okay. Suddenly you're coming out with an electronic that can do this high power thing. You see the price of electronic. I bought one electronic Tri-X, 80 ringgit one. This connector is only about 29 ringgit. Okay, so sometimes you have to think logically lah. So the FIP was wrong. I was the one who examined him, but I didn't want to bring down too much. Actually, should be failed. He didn't consider all those things. That FIP should fail because he said I want to use a chip to replace this contactor. Where for me it's totally wrong. That should be a failed project already. Okay. 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 So you have to take. Then you take photo of this also. But this is not Autotran circuit. It's another circuit called starter. There are two main circuits used in motor starters, starter and Autotran. Okay. So what is the purpose of it? Okay. There's two things. Okay. Okay. These are the two words. Purpose is electrical stress and mechanical stress. Okay. So both of it are related to both of it related to inertia. Okay. You see how to explain it. I wrote in my own exam. It's a score like a cupboard. Okay, a cupboard, big cupboard. You push it. Initially, it's very hard to push. You can actually write that in your exam. That's what I wrote in my exam in score. A big cupboard. When you push it, it's very hard to push initially. After a while, it's easy to push because you've already overcome the inertia. Okay. That's how the world works. I mean, it's just like similar to send a rocket to the moon. You need a certain boost power. Then only you can get off. You see? That's similar to the inertia. Okay. So you need a certain inertia. Then only you can overcome it. To send a rocket to the moon, you need a certain big power. You can get an escape velocity out of the Earth. Okay. So that is the inertia. Okay, things like to stay where they are. You need some extra power to get it off from where they are. That's inertia. Okay, so a small motor you don't worry about much, but imagine a motor is as big as UCTS classroom. Okay, the rotor is as big as a classroom. It takes a lot of energy for it to get started. And motors and all machines, they will draw the power. They don't have power, they themselves will draw. So that's why humans don't determine the amp. The amp is determined by the machine. Okay, we determine the voltage, the total power. Okay, but when equipment want power, it would take in more power by itself. It draw the amp more. Okay, the amp is always determined by the machine. We determine the voltage, and the amp is determined by the machine. The machine wants more, it just take in more. Okay, so normally in most cases for big motor as big as a classroom one, the amp that they pull in during starting to overcome the inertia is double. I asked one of the engineers who was my student in Taiwan to measure. So the starting is 40 amps. Okay. Okay. So the starting is 40 amps, the running 20 amps. That's why the final device before going to the motor is called the overload relay. Okay. Okay. So the overload relay has a variable amp. Why? Because starting is 40 amp, right? So when you want to start, you put the relay at 43. Yeah, a bit higher than what is it using? 43. Yeah, so you can start. After already start, you put it down. Because starting is only 6 seconds. The human is still there. Okay. So after starting already, you put it down to 6. Because running is 20, so you put 23 or something like that. Okay. So 43 to enable to start. After starting, you put it down to 23. If you keep it 23 all the time, what happens? You cannot start. So starting, you take 40, so you cannot start. Okay, so that's why this one overload relay has a variable current. The MCB in the house works almost exactly the same way as the overload relay. They use bimetallic strip. Okay, but MCB is fixed amp. Okay, if fixed amp, say you put a 23 amp there, MCB to start a motor, it cannot start. Because starting you take 40, 6 seconds you start, take 40 amp. So the motor will never start. The circuit breaker always trip. Okay, so that's why you need 43 first. You tune it 43. After already start, you tune it back to 6. Sorry, you tune it back to 23. Okay, understand, huh? So electrical stress is you pull in too much amp, you take 40 amp, the coil within the motor will get damaged. Okay, that's meaning electrical stress. And then mechanical stress, you see the induction motor is only 2 points of failure. The coils around the stator and the 2 end bearings, the 2 end got bearings, right? That one will also have too much mechanical stress. Okay, so you have electrical stress and mechanical stress. They will damage the motor if you don't use a starter. So the starter will reduce in Autotran. Okay. So the starter is used to reduce the voltage to 290 volts. Okay, for 6 seconds. After 6 seconds, go back to 415. That's the whole purpose of the Autotran starter. Okay, so remember this is your assignment, and then I'll ask you in your final exam also same thing. Okay. So that's why I want you to examine it. And then later, when you go out to work, you need judgment cert. 100% this will come out also in your judgment exam. Okay. So you reduce voltage, so the whole power, because if it is full power, if 415 volts going in from the beginning, you still take in a lot of amp, right? You take in double the amp. So the power, which is the one that can kill the wire, is reduced by half, because instead of 290 is about half, okay? So the power going into the wire, which will cause the wire to burn, the coil wires in the stator of the motor, is the whole power. The power is the one that makes it hot, okay? So the power is reduced by half. So that's why you can reduce electrical stress and mechanical stress, because the power is reduced by half. So remember the reason, 100% first core exam, they'll ask you the reason. In my exam also, I'll ask you the reason for it. You're building it, but why? The reason is this: you're reducing the power by half. Okay, roughly half. Okay, get it, huh? Okay, I'll send you all these notes. So I'll see you tomorrow, online class again. Okay, since we can't do classroom class. Okay, so see you tomorrow.